S-domain circuit analysis. First, we have to discuss on how to transform a T-domain circuit to S-domain circuit, or finding its equivalent Laplace model. Note: the initial conditions ILO and VCO are considered on a circuit having a switch or not, but still, the value of these initial conditions on the circuit not having a switch are zero, and their equivalent Laplace symbol is broken line figure. For example, this is a circuit having no switch. The source is labeled as V of t, which is equivalent to U of t, and the voltage across the capacitor is Vc of t. This is the equivalent Laplace model. Where all the voltages are in S-domain and the initial condition VCO is a broken line figure. Solving for Vc of S, or the voltage across the capacitor, using the voltage divider, we have Vc of S over S is equal to V of S times the fraction of 1 over 3S over 2 plus 1 over 3S is now equal to the quantity of V of S times the fraction of 1 over 3S over 2 plus 1 over 3S times 3S over 3S, which is also equal to 1. It's now equal to 1 over S times the quantity of 1 over 6S plus 1. Using partial fraction, 1 over S times the quantity of 1 over 6S plus 1 is equal to A over S plus B over 6S plus 1. The equation now to solve the value of A and B are: A is equal to 1 over 6 times 0 plus 1 is equal to 1, and B is equal to 1 over negative 1 over 6 is equal to negative 6. Then 1 over S plus negative 6 over 6S plus 1 is the answer. For the inverse Laplace transform H of t, this is equivalent to the quantity of 1 plus e raised to negative 1 over 6t u of t. Using the formula, u of t is equal to 1 over s, and e raised to negative 80 u of t is equal to 1 over s plus a. For a T-domain circuit having a switch, we have having a source, resistors, inductor, and a capacitor. For the initial conditions ILO and VCO. After getting this initial condition, I of S can be solved using inverse Laplace transform. Based on the switch at t is equal to 0, the circuit is initially closed. Therefore, for shorted inductor and capacitor, we have the circuit where ILO is being solved using Ohm's law or Kirchhoff's law. For the voltage at the inductor and capacitor, we have where the opposing voltage at the inductor and charge voltage at the capacitor branch are all because of the initial conditions. This is the equivalent Laplace model with the current I of S, which is the current flowing in the circuit in S domain. Z transform, transfer function, and block diagram. This is the delay element for Z transform and has a function of shifting in a system. On this diagram, the delay element acts as a system 0 raised to negative 1 for the input x bracket z and output y bracket z. There are two types of feed on a block diagram of a system: the feed forward and the feed backward. Notice that the direction of the arrow shows the type of the feed. Consider this block diagram having a feed forward and a feed backward. The negative 1 on the feed backward arrow acts as a multiplier before entering the delay elements. Consider first the easiest part of the diagram from input to output. The equation now will be y bracket z is equal to x bracket z times z raised to negative 1 times z raised to negative 1 is equal to z raised to negative 2 x bracket z. Considering the feed forward of the block diagram, the equation now will be y bracket z is equal to x bracket z times z raised to negative 1 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 is equal to z raised to negative 4 x bracket z. Adding this to the first equation, we have y bracket z is equal to z raised to negative 2 x bracket z plus z raised to negative 4 x bracket. Considering the feed backward of the block diagram, the equation now will be y bracket z is equal to negative y bracket z times z raised to negative 1 times z raised to negative 1 is equal to z raised to negative 2 y bracket z. Adding this to the equation, we have y bracket z is equal to z raised to negative 2 x bracket z plus z raised to negative 4 x bracket z minus z raised to negative 2 y bracket z. Note, all the terms with y bracket z will be the denominator and all the terms with x bracket z will be the numerator. Finding the transfer function h bracket z, we have y bracket z is equal to z raised to negative 2 x bracket z plus z raised to negative 4 x bracket z minus z raised to negative 2 y bracket z. Then y bracket z is plus z raised to negative 2 y bracket z is equal to z raised to negative 2 x bracket z plus z raised to negative 4 x bracket z. Y bracket z times the quantity of 1 plus z raised to negative 2 is equal to x bracket z times the quantity of z raised to negative 2 plus z raised to negative 4. H bracket z is equal to y bracket z over x bracket z is equal to z raised to negative 2 plus z raised to negative 4 all over 1 plus z raised to negative 2. It's now equal to z raised to negative 2 times the quantity of z raised to negative 2 plus 1 all over z raised to negative 2 plus 1 is equal to z raised to negative 2. Finding the inverse z transform of z raised to negative 2, we have h bracket n is equal to the inverse z of z raised to negative 2 is equal to delta bracket n minus 2. Difference equation. Note, to formulate the difference equation, separate the terms with y bracket z and x bracket z will transform their delay element or shifting to n domain. The y bracket z will be y delta bracket n minus a and x bracket z will be the x delta bracket n minus a, where a depends on how many times the function being delayed. For example, getting the equation of the previous example, we have y bracket z plus z raised to negative 2 y bracket z is equal to z raised to negative 2 x bracket z plus z raised to negative 4 x bracket z will be equal to y delta bracket n plus y delta bracket n minus 2 is equal to x delta n delta bracket n minus 2 plus x delta bracket n minus 4. Laplace transform, transfer function, and block diagram. This is the transfer function element for Laplace transform and has a function of antiderivative in a system. On this diagram, 1 over s acts as a system for the input x of s and output y of s. Note, the types of feed is the same also on Laplace transform if we are dealing with block diagram of the system. Consider this block diagram. Consider first the easiest part of the diagram from input to output. The equation now will be y of s is equal to x of s times 1 over s times 1 over s is equal to 1 over s squared x of s. Considering the feed forward of the block diagram, the equation now will be y of s is equal to x of s times 1 over s times 1 over s is equal to 1 over s squared x of s. Adding this to the first equation, we have y of s is equal to 1 over s squared x of s plus 1 over s squared x of s is equal to 2 over s squared x of s. Considering the feed backward of the block diagram, the equation now will be y of s is equal to 1 over s y of s. Adding this to the equation, we have y of s is equal to 2 over s squared x of s plus 1 over s y of s. Note, all the terms with y of s will be the denominator and all the terms with x of s will be the numerator. Finding the transfer function h of s, we have y of s is equal to 2 over s squared x of s plus 1 over s y of s. Y of s minus 1 over s y of s is equal to 2 over s squared x of s. Multiplying both sides with s squared times the quantity of y of s minus 1 over s y of s is equal to 2 over s squared x of s. S squared y of s minus s y of s is equal to 2 x of s. H of s is equal to y of s over x of s is equal to 2 over s squared minus s. Using partial fraction, we have 2 over s times the quantity of s minus 1 is equal to a over s plus b over s minus 1. Solving for a and b, a is equal to 2 over 0 minus 1 is equal to negative 2, and b is equal to 2 over negative 1 is equal to negative 2. H of s is equal to negative 2 over s plus negative 2 over s minus 1. For the inverse Laplace transform, h of t This is equivalent to negative 2 times the quantity of 1 plus e raised to t u of t. Using the formula, u of t is equal to 1 over s and e raised to negative at u of t is equal to 1 over s plus a.
優しい色した空を映して高層ビルがやけに綺麗だ行き交う人たちそれぞれの胸の中で景色は変わる